This is the second presentation in my channel of business process architecture. As the title says, it is about complexity in business processes and not complexity and business processes. There is a subtle difference. When layers and layers of simple business processes are put on top of each other or tied to each other, their elements tend to interact with each other. When I say elements, I mean actors, actions, and it creates complexity. This complexity is emergent by nature. The characteristics of this complexity is often unknown because it did not exist before. Many of the past scholars who have dealt with processes and organization did not deal with this complexity because they didn't simply understand it or could not correlate it to the works of Edward Lorenz, etc. Fundamentally, complexity creates a nonlinear effect in the processes because processes are linearization of complex mechanism. As I have said before, process complexity is not a well-defined topic. There are hardly any literature around it. The topic of complexity has tremendous amount of literature. Especially the areas of nonlinearity and chaos have been studied. I believe those studies can be applied to process architecture too. One of the goals of process architecture in its current state is to reduce the randomness and nonlinearity and make processes linear by nature. This helps us control processes. Since our process logic are always controlled by if-then, if-not-then boundary conditions, so linearity turns out to be our friend. So in order to do this presentation, I have used few past literatures. One is the Zachman framework of structure, and the links are here. Another one is the Warren Weaver's Science and Complexity paper. It's a very famous paper. Another is a pretty unknown paper from somebody called Brad Mercer of Mitre Corporation. At that time, he was working in Mitre Corporation. And you can see in slide share, there is a presentation of him on engineering and architecting, the difference between the two. And I believe it's a fantastic presentation. Anyhow, I'm going to refer to them in my throughout my presentation. We'll use the term architecture and architecting quite a bit. So I'm trying to create the definition or trying to show you the definition of architecture and architecting. Architecture is a noun and it's an intrinsic quality or property of a system consisting of the arrangement and interrelationship, both static and dynamic, among its components and their externally visible properties. Now the important term here is static and dynamic. We know how to deal with the static things pretty well. Our knowledge of dealing with dynamic things in process is very limited. The structure or form of the system is the final architecture. Architecting employs synthesis of the form to iteratively compose separate elements to form a coherent whole. That means you have many functions, you have many actors. How do you put them all together and represent a whole process? That's basically synthesis of the form. So what is complexity? Or rather, I should ask, what is complexity in the context of business process architecture? It is the interaction between the process elements or variables, like actors, actions, data, which cannot be quantified by simple historical data analysis. That means if you just look at the historical data and try to figure out what's going to happen, let's say in loading a truck, But suddenly there is a storm, and what we did not consider, the interaction between the wind and the tarp covering the truck. But it's a very real interaction between two elements, which changes the process completely, or maybe even stops it. So the outcomes of these interactions are unpredictable. One other example is one role can perform a duty in one country, but the same role cannot perform the duty in a different country. It's the same duty, but the roles are same also. This calls for two process models, one for each country. That's also a type of complexity, and we are using a reduction mechanism of creating two process models in two countries. We are going to use a simple process to go through this process complexity issue. The particular process we are using here is the purchase of a cell phone, then activation of the cell phone, and then fit it with a SIM card. Of course, buy the SIM card in the meantime and start using the cell phone. It's a very simplistic process. As you can see, a buyer does research on cell phone. It can be an internet-based research, or he can travel to a store and test various cell phones. Even after internet-based research, we go to a store and do the research. Then we purchase a cell phone. Then we activate the cell phone. Then we use the cell phone. Now this purchase process can happen through the company which provides the cell service too. So there are multiple choices here. We're going to go through some of these processes steps. And as you see in yellow oval shape, we have the actors, whereas in the blue shapes, we have the actions. The actors are the buyers, sales agent, technician, etc. So we are going to go through it in three scenarios, which I will show a little later. This is the Zachman framework. This Zachman framework is very famous in the architecting community. It asks the 6 primitive questions: why, how, what, who, where, and when. These are the essential and basic components of a process model. In order to develop a process model, you need these 6 questions to be answered, or at least partly. And that's on the, you see, on the vertical axis. But on the horizontal axis, you can have 3 levels. Even though in the Zachman framework there are 5 levels, you can have 3 levels, which is conceptual, logical, and physical. This is a tremendously powerful model which can help you develop any process model and store all your information into particular boxes of this matrix. As you can see here, I have taken the Zachman framework. I have the 6 primitive questions in the x-axis or the horizontal axis, but then I have put the 6 primitive questions in the vertical axis too. And it is the interactions between these questions or the answers to this question which creates complexity. Because many of the time we do not know. For example, when an action is performed in America versus action is performed in Asia versus action is performed in Europe, they may have different results and they may be performed by different roles and they may be performed at different times. So there are interactions, and that is what makes the processes complex. In the bottom, you will see we have the business processes, which are primarily the how we are performing the actions or activities and who is performing it. But then we have the variable interactions, who and where they are performing it. Means different things. And then there is the data interaction of who is allowed to use what kind of data. And by the way, a data here can be a physical component too. These are the headers for the next 3 slides. And this is directly from Warren Weaver's paper, Science and Complexity. The first is problems of simplicity, then the problems of disorganized complexity, and then problems of organized complexity. As you can see, a problem of simplicity do not answer 99% of the real-life questions and can be looked at as the lowest common multiplier. Current methods of architecting processes typically turn everything into problems of simplicity. There are very limited interactions and dependencies between the variables. All dependencies are linear or binary by nature, which essentially means if-then logic. Typically, answer how and who is going to perform it, how they are going to perform it. That answers your process model. Now, the cell phone research, as you can see, done by a buyer, and the buyer travels to the store. And there is a possible interaction between a buyer and the sales agent. When they are buying it, there is a possible interaction between a technician at the carrier company and the buyer. And they are buying when they're activating the cell phone. So when the technician, the buyer, and the sales agent can have an interaction also, all three together. For example, the buyer buys something and the sales agent has sold it to him, but the technician cannot make it work with the carrier. So there will be an interaction. But those kind of things are not really part of the process drawing. And these processes are problems of simplicity that we show here. Next, I'm showing problems of disorganized complexity. It has a lot of unintended interaction. Now, example, a lot of people around the world are doing research on purchase of cell phones using various methods. They can talk to their friends, they can look at internet, they can go to the store, they can look at somebody else's phone, etc. Then a lot of cell phone manufacturers manufacture a lot of models of cell phone. And they, by the way, these cell phones each have different communication standards. Now each country have different carriers, and these carriers have different standards. So these carriers cannot use all cell phone models or all manufacturers. Sometimes due to government laws, certain manufacturers cannot work in another country. Even if the standards match, there are a lot of specifications which are not allowed by carriers, like a locked cell phone versus an unlocked cell phone, etc. There are SIM cards of various types, eSIM cards, normal SIM cards, and large SIM card sizes, small SIM card sizes, etc. And many people are using cell phone for various purposes like phone calls, browsing, texting, camera, music. Now, as you can see, all these things can have various interactions, and these are millions of things which create problems of disorganized complexity. We take the problem of disorganized complexity and turn it into a problem of organized complexity. We deal with a known set of interactions and pretend others do not exist. The other interactions exist, but their effects on the entire process is so low that it does not have any perceivable effect on the process, unless something catastrophic happens, by the way. So how will that problem of disorganized complexity turn into a problem of organized complexity? Now, instead of looking at the whole world, we are looking at a small portion of the United States, a specific region. Now, there are specific number of carriers in that region who have very specific carrying standards. There are limited number of cell phone manufacturers who support these carriers in that region, and they follow the standards of those carriers. Like in the United States, there are two standards typically for cell phone, one used by AT&T, T-Mobile, and another used for Verizon. And also within the GSM system, which is used by AT&T and T-Mobile, there is 3G, 4G, 5G communication standards. Now, when a cell phone buyer buys a cell phone, they buy it for one of these carriers or something which is allowed by T-Mobile and AT&T or Verizon, etc. They don't buy just a cell phone, any cell phone, which is not allowed by any of these carriers, because then they cannot use the cell phone. So suddenly we see our options are much more limited. We have very limited region, we have limited number of company carriers, we have limited number of companies making cell phone. So the problem becomes much simpler, and the answers to all these complexities that may arise, we know the answers to them. This is how we turn the problem of disorganized complexity into problem of organized complexity. Conversion from disorganized to organized complexity will require certain engineering activity, process engineering activity, before we can architect or model that process. Organized complexity allows the use of process patterns which can be used for similar cases with minor variations, like companies who are in completely different industry can use the same purchasing process. In this particular case, in our example, understanding the underlying communication standard offered by carriers is most important. That is what simplifies the whole process, because the number of companies offering cell phone, number of cell phones they offer, SIM card, everything is controlled by that, the communication standards. Then the capability of phones to use such standards, because it reduces the number of phone models from 5,000 to 50. I mean, the magnitude is really 10-folds, 100-folds. Then the SIM card standards, because in many countries they don't allow eSIMs. Then the activation methods of the phones. If you have eSIMs, then that can be activated over the internet. But in many countries, actual physical activation is required, where you go to a cell phone company, a store, to get your SIM card activated. The three examples of process complexity explained: problems of simplicity, two-agent interactions, that's the maximum, 2 or 3 decision points, it's easy to model. Problems of disorganized complexity, n number of agents, few hundred carriers, 30 phone companies, few thousand regions, various prices and taxes, various standards. you cannot model them. It's almost impossible to model. So then in between the two, you have the problems of organized complexity, like 5 carriers, 3 standards, 8 phone companies with about 100 phone models, few thousand consumers every day. Limited channelized interaction. Architecting and modeling this process can be possible only when it's engineered to a certain degree. But it's possible. So this is the difference between the 3 complexities. Looking at it from a higher level, the top level represents problems of disorganized complexity. The second level represents the problems of organized complexity, whereas third level in the bottom represents the problems of simplicity. This is kind of a very simplistic way of representing the problem, but if you have to take one slide and understand how the problems of process complexity works, this is exactly how process complexity works. Thank you for listening to me.